Next up, we have virtual destructor and dynamic casting and few design patterns in C++ we will discuss. We have our prompt ready. Let's go through that. And prompt is here and user instruction. Let's discuss virtual destructor, dynamic casting, and some design patterns in C++. And virtual destructor is very important in polymorphism concept. And we'll see that. Dynamic casting is also a polymorphic behavior we need to learn about. These are advanced concepts. And strategy design pattern, factory design pattern, they use this virtual mechanism, and that's why they are very important design patterns, very commonly used as well. We have a design pattern course, so we will dive into 20 design patterns in it. And here we just briefly discuss this design pattern, this C++ virtual mechanism to that applies to design and design patterns like factory, strategy, and all. So code expectation is include the print statement or cout and use the constructor, destructor, successful failed casting on all this. So it should show us how does it work. And our goal is to teach the students or learners, beginners or experienced. Now, as we are diving into the deeper concept of object-oriented programming, these are mostly advanced concept. This is something the beginners will struggle to understand. As we are going step by step from the early stage lesson 1, 2, 3, 4, and this one is a little bit advanced. So if someone has gone through the lesson 1 through 4 or 5, this should be easier. So these are some advanced concepts. And let's ask our Copilot to generate code, and we submit this prompt. And GitHub Copilot is working. It says that it's working. We'll give a few seconds to start working. It's going through the prompt and formulating the code. That's is started. And here we go. The code is getting generated. Text document. First one is document, text document, and image document derived from document. And okay, it's display something. Get the height and width of the image and demonstrating virtual destructor here. And then dynamic casting is used, and dynamic cast to the base class derived class pointer, and processing the strategy design pattern, print strategy, and encrypt strategy, export strategy. So here is a document processor using the strategy class and demonstrating strategy pattern here. That's it. Oh, here is still going on. Create document, and there's a main. So we got the virtual destructor in this demonstration, dynamic casting, strategy design pattern, and factory design pattern. We asked for these four things. And here there's a lot of code, and we take this to the editor as we did in earlier lessons. Object-oriented features and design patterns. We have this says apply in editor. We will apply that. Click on that and create a new file. We call it advanced cpp.cpp. Let's do that. Advanced cpp c++.cpp file, and it is created. Advanced cpp here, and now hiding the chat window with GitHub Copilot. We have the code here in our editor. We have 4 items here, the file description on the top, and in the header files included. Here's one memory. We haven't seen that before. Map, vector. These are the TLS standard template libraries, and type info, string. And let's go through the code and execute. First, we will compile, then we will run it, and compile is C++, file name, output, and output file name without extension, advanced CPP, and compilation is done. We have ls-ltr, we'll get the last one here, and advanced CPP, and we do have, let's clear it, oops, clear, and dot advanced CPP. Run that, the outputs will be here. And we have the code. Let's go to the code and go through the output. Output starts here. Advanced C++ object-oriented programming features and design patterns. And that should be in the main, and main is in the bottom, at the bottom. And demonstrate virtual destructor dynamic casting, strategy design pattern, and factory design pattern. So each one, and let's go through the classes first, and then we will dive into the execution part. We have a document class that's a base class to, and both document has a name and content. And it has constructors, destructor, virtual destructor. That's what we're talking about. We have a virtual destructor. It's critical for proper cleanup because we'll see that when we execute. And text document derived from document, and this has a destructor as well. And why virtual will be text document. Text document is the it's a destructor here. Display of the base class is called here within the display. And image document is derived from document as well. And image has a destructor as well. And display function. Demonstrate virtual destructor here. So we see that virtual destructor. Case 1, proper cleanup here, proper cleanup. How does it work? We have the document base class pointer doc1, and we have a new, that's is memory allocation happening here with a file name called report.txt and the content. So, and then we have base class pointer is actually calling the display. and then deleting that doc1 base class pointer. Here is the magic. Proper cleanup calls text document destructor, then the document destructor. So delete will call the destructor using this pointer. So this pointer is a base class pointer, but this is pointing to a derived class object. That's a text document. And what happens here is, here's the output we'll see. We have document constructed, text document. The constructor, base class constructor is called first here, document, then the derived class constructor, and then displaying through the base class pointer, the display here. And it displays the document name, the content, and the word count. And now deleting the base class pointer here, deleting the base class pointer. And first it will call the destructor of the text document and then destructor of the base class. Derived class destructor gets called first and the base class destructor called later. So this is because that's the virtual destructor is in play. Without virtual destructor, this derived class destructor would not have been called. So that way it might leak some memory, and meaning if this text document in the constructor, it is if it has some, here is a new, new. This new integer word count. This is a pointer. This is a simple pointer that there could be somewhere it could be much more larger. In the real life example, a huge memory could be lost by just not doing proper virtual destructor. So in this case, word count is deleted here in the text document. So if we do not have the document done here, virtual destructor, if this destructor is not virtual, if we remove the virtual keyword, then that memory byte integer size will be lost in this. So this will not be getting called. So in this case, it is getting called. No, this is getting called for this one here, and before that, this destructor is getting called, so it is deleting this memory. Without that virtual destructor construct, it will lose that memory pointer, the new, whatever it is done. At this point, maybe sometime a megabyte or gigabyte based on the applications we have. So that's about the virtual destructor. And same case 2 has case 1, case 2 similar is image file. It is base class destructor and then image document. And then here the cleanup is happening, cleanup of image data of this size image file. So what's happening in the image? Image is the new unsigned width into height. This is what I was talking about. It's a huge size. It's 800 by 600 bytes. So this could have been lost without that virtual destructor mechanism. So that's the demonstration of the virtual destructor. And this is this is the second different derived type. And some description, we can read this. Only the base class document destructor would be called without this virtual. If virtual wasn't, we discussed that. And word count memory would have been leaked. Image data would have been leaked. So the memory would have been leaked. Memory leak could happen that way if we do not have proper virtual destructor defined in the base class. So demonstrating dynamic casting, this is another important concept, and it has a vector of that document. We saw the document pointer is a vector, and we have one object is created new using new text document, image document, and the base class itself. So we have three different types of object in this documents vector. And using that in the for loop, what we are doing is document, first one is document, we print that or get name of the document that is displayed, dynamic casting here, document notes, text, and I think we're talking about dynamic constructor, document, constructor, doc. That's a different one. A processing here. Okay, that's in the constructor. Okay, the constructor is displaying correct values, and here is this result in the for loop. This document, this is the one. So text doc dynamic casting. Attempt to cast a text doc, and if it is this one, the first one, text doc, then this dynamic cast will be not null. If it cannot be converted, this doc, the pointer cannot be converted to text doc, then this will be null pointer. So if not, then this is the correct one, and it is calling the text doc get word count. And similarly, if that pointer is of image document type, this will be successful. The dynamic cast will be successful if that is of type that object. So this is called downcasting. So if it is not, then it will be in else part, not an image document. Otherwise, image height and width will be displayed. Here is that image height and displays dimensions, and otherwise, and document three, and where is document three? Document three. Oh, document 3 is not an image type and text type, so it will only display the name. So here it is, not a text document. That's the one, not a image document. Actual type is this. Okay, so after that it is deleting using deleting the pointers using the delete. So what's the notes here? Key points about dynamic casting is only works with polymorphic type. So classes with virtual functions. The classes with virtual function. The document has virtual functions. It has to have. The returns null pointer for the null PTR for the pointers, or throws a bad cast for references if cast fails. That's we saw. It is here. It cannot cast. Next, enable the safe downcasting in inheritance hierarchies and requires RTTI runtime type identification. That is the dynamic cast mechanism. Runtime type identification it will do. Next is in our main strategy design pattern. So strategy design pattern is one of the important design patterns. And same thing, it is using text document, this, and then there is a document processor class. In that we are sending make unique print strategy. Print strategy, another class, which is creating a processor with initial print strategy, and then using that processor call process document, and then set strategy, another encryption type. Then you call that process document. So it is the strategy is set to the new type, changing the encryption strategy, and then changing it to PDF export strategy, PDF export. And that's how the different strategy, different document types will be printed. And this is how it's implemented. If we go through this process document, there should be something called process. Strategy is another processing class. Processing strategy class is a unique pointer. Using that, it will print that process document, that particular object that we passed. And in the set strategy, we saw that the different print, export, all of the different type of strategy objects are set here, a new strategy. After that, we call process, and then it will call the write function of the method of the write object. So that is the strategy design pattern. And this is what it is. And what is this used for? The key points about the strategy design pattern is it defines a family of algorithms, strategies that we saw for document different type of processing, encryption strategy, export strategy, and print strategy, different family of algorithms. Make them interchangeable at runtime. At the runtime, we saw set strategy will be setting up that particular one and separates behavior from the context. So we are calling the same processor, process document. It's the same way where internally it will be calling the right one at that moment. Eliminates the conditional statement. So here there is no if-else condition, like if export or print or encryption. It is just updating the object, creating an object with the new strategy, and then calling it. And promotes open close principle. That's another object-oriented concept. Open close principle is open for extension, closed for modification. That's something called solid principle, and that is in the that we'll discuss in the design patterns. Solid principle, SOLID, that's the acronym, and O is for open close principle. And we have now factory design pattern. In the factory design pattern, we have text, image, spreadsheet, and presentation enumeration type, and spreadsheet document, and presentation document. These are classes. Document factory. Here is the factory, is create document. So based on the type, here is the switch, and then so we saw in the strategy, it is updating the object, replacing the object, and then calling. Here, you pass the type of the document. So, and then it is a conditional switch case. And whatever type of that create, okay, when it is calling create document and passing the type, only that type will be created and returned to this. And we have the implementation here. Let's see, factory, and here, factory. Yeah, factory design pattern. And we have the vector. So let's see. Oh, we didn't go through the output for the previous one. You can see that. This is the strategy design pattern, export, export, and then HTML. This is a PDF, and then HTML, and so on. Let's see the factory design pattern demonstration. This is the constructor creating. So here it is. Creating the document by type. In the vector, it will be creating that object and pushing into the vector. And create document, what is the type? Text. Create document, what is the type? Image. We saw that. And a spreadsheet and presentation. So all these are created here. Presentation, the when it is created, the constructors are called, and these are printed in the constructor. Now, creating documents for file name and creating documents for file names, document from file names. So there are two factory method: create document and create document from file name. It should be here. Yeah, that's the one. And in that, this is also if the extension is this, or this, then create the text document. Otherwise, if this is an image, it will image document. If it is Excel sheet, CVS, Excel sheet document. Is it PPT or PPTX, this document. So in this place, we have that object is created based on what is the type of the, so node.txt, JPG. If we go back, the extension is extracted from that using the substring of the extension dot position. Find the dot position in this, the file name, find the last of this dot. There could be dot, many dot, but last one is extension. Find that position, and then using that position, you find the extension. So that's why it is based on that extension, either txt, doc, or rtf, and all other images are JPG, PNG, and GIF, like that. So those are the objects created, and after that, because this is a vector, so all there are 8 entries in the vector, and 8 entries are here displayed. First one, report.txt, logo, budget, pitch, note, chart, all we saw that, and data CSV, slide, that's a slide, and then unknown, that XYZ. And then when it is displayed, here is a display, and after that delete those documents, it will call their respective destructors, and these are here. The structures are called base class destructor and the derived class destructors. All of them are called. And first derived class, then the base class, same thing, derived class and the base class destructor are called in that order. And here is a note. where does it help having a factory pattern? Encapsulates object creation logic in central place, creates object without exposing the instantiation logic. So every derived class has its own logic, it doesn't expose. Return objects through the common interface. That's the base class. We saw the document. Document is a common base class to all of these derived classes. And make makes code more maintainable when adding new types. So we can add a new types easily in this case. And that's what it is. Promotes a loose coupling between client code and the object creation. So this is the client part, this function, demonstrate factory. This is a client for all of these objects that it created. And so that's loosely coupled. They can be changed, they can be replaced, they are not tightly coupled. If I remove this line, it will work fine. If we remove 5 lines of this or 4 entries of this, it will work fine. So that's why it's called loosely coupled. They are not tightly coupled. And that's about the advanced CPP concepts, virtual destructors, dynamic casting, demonstrating strategy pattern, and factory patterns. And there are many more. Using this concept, you have all the object-oriented design patterns uses this concept. They use all these object-oriented concept, polymorphism, inheritance, and abstraction, all of them. So with that, we have concluded this advanced CPP concept, and we have much more coming. The complex part is still there. C++ is really complex, and we understand this. All programming language will be easier. And with that, and thank you so much. I will see you in the next lesson. Thank you.